Hello guys, in this episode I want to introduce the building of a a drawing box that it used in drawing the plastic filaments for the 3D printers. And here is the finished one. And because previously I have some made dry box. There is a locking here, and it can be separated out for installation of the filaments inside. This type of filament, and it's just for storage use. Sometimes almost 10 years ago I built this, so I have excess ones. Now I use it to build a drying box to remove the moisture in the filaments. And I want to explain more here. This is made of I think it's 3mm or 4mm thickness plastic, acrylic plastic, and glued with the silicon rubber. And here is for putting the filament. So this is just a fittings for hose fitting. This is for this type of hose, and this is the lock, and there is sealing here. And here put the filament put here. There's nothing else. And desiccant will be put here in before. That's okay for this. And now this one is there is the electrical inside heater. And I want to explain more. For my 3D printings, I will use this drying board to dry the filaments, to remove the moisture. Afterwards, I will take it out and put it into a sealing bed, and I will use this big pump. It's very cheap. Now I bought it from China. I live in Hong Kong, and I bought these components or parts very easily and convenient. And this bag also, and then suction out the air. And I keep this one for almost 4 months, and it's still in a good shape, in a vacuum manner. This one is, what is this filament? This is natural color POM. And for this drawing box, let me introduce Here is the 3D model. And heater assembly is here. You can see these actual parts. And this curve shape is a 1 millimeter, I think 1 millimeter thicknesses aluminum sheet and been bended, and it was bended in curve shape. And this one is the fan, cooling fans or suction fan. Is I think 40 millimeter by 40 millimeter, and this one is thicker. Actually, this is two fans come together, so the suction air power is much greater. I use around 5 to 7 volt to power it, and the air come out is quite okay. And this one is a aluminum heatsink. I bought it. I think it's for computer use or something. Anyway, heat assembly, and then I use this ceramic heater. This is something like this. It's a PTC ceramic heater. There is some PTC ceramic inside, and there are two metal plates sandwich them, and we can put AC power here into it. I use 220 volt, and there are, because this one is the power is low, you can buy bigger one. I have this piece in my storage, so I don't need to buy. I just use it. So I just use it, and I use more pieces. Here is 1, 2. Here is another 3. Here is another 2. I don't draw it. And in choosing how many pieces of this ceramic heater required, you need to do some measurement, and you can check individually your PTC heater's rating or current draw. And in the whole box, the weightage, power weightage should be around, at maximum is around 115 volt. It should not be too high, otherwise it draws too much current, or its temperature will rise up quickly. And you can measurements the total AC line power or current draw is around this at 220 volts. 220 volt times 0.7 is something like this. In the markets, the dry box usually is around this power rating, and you can switch it in different temperature for different voltage power draw. But it don't care it, since in this operation, the operation of this machine is a power on and off. It didn't do any PWM duty cycle, so just take measurement of the current draw at the maximum situations, and it's much complicated to use PTC heaters, and you can choose to use other heating wire methods. For the hair dryer, the power rating is much higher. You can see this is 1700 volt, and in next video, another video, I will introduce the use of a heater coil of a hair styler. Hair styler have a lower power rating, and you just take out the heater coil and use an exhaust fan. Don't use the fan of the hair dryer, and put it here. So the construction will be much easier and simple. You just make use of the slow cooker or some other electric appliance touch panel, and use a hair styler coil, heating coil, and add a exhaust fan, and then to complete the building of this dry box. And another aluminum plate is here. So I CNC milling this aluminum plate with this groove. Take care the dimensions, and don't let it damage the insulation, otherwise it will blow out. I blow out one pieces because such sockets or the pieces is not good enough. And this is the plastic 3D printed parts, 2 pieces, and the whole assembly is mounted on the bottom by these tie pieces with 4 screws. And this aluminum sheet is clamped between this aluminum plate and this heatsink, so altogether it is an assembly. So going to this, and there is a desiccant, a batch of desiccant put inside here. You can say white cloth bag, and we will put in here. And there is opening here for air escape out, for the moisture come out. And if for sealing, I will close it. When heating, I will open it, and here is for the filament coming out. and the filament will go here and come out. For the panel, let me show the panel, the trainer. This is a panel assembly, and the electronics parts is inside. And you can see here, and the power supply is here. You can I use a old pieces. I think it's AC. Oh. It's not quite 9 volt DC, 9 volt, some 115 mA. And so there is two power lines. This is the DC 9 volt. This is the AC 220, and AC come into here, and this is the power switch, on-off switch, and this is the DC 9 volt input. And sorry, and here I plug in, and the panel is almost light up. This is power on off, and it will count as the time is increasing. Actually, it is now I program this in seconds for this first digit. Later on, I will use this for demonstration. Later on, I will convert it to longer time to minute. So after then, this is the increased time. Actually, you can't see the label there, because in the original panels the characters or the letters will be, the wordings can be seen, but it's not now. I increase the time. The increment is 13, and it's 16. So there 2 hours or 2 minutes, and then here is the start. Before start, I need to select the heating levels. This is the high, low, lower, high, middle, low. There's 3 heating value I can choose, and after pushing this, it will start heating up, and this light show is cooking. Once the temperature reach this value is the high value, I set this to something I forgot, is 18 degree, and middle one is 16.5, and the lower one is 14 degree. When this temperature reach, then the heater, there's no power to the heater. These lamps will be turned off, and this keep warm lamp will be turned on. And once it started heating, the set the time. Before that, I increase this time to set this time to 2 hours or 2 minutes something. Then it will start to count down. It will decrease one by one, 13.4, 13.3, 13.2, until it go back to 0. Then it finish, and it will turn off. And this is the increase up, this is the increase down, and that's the function of this touch panel. And I didn't open this power. Actually, I need to open this. The 9 volt, when I plug in, the 9 volt will always go into it, and this will operate as the heater. I need to turn this on, and the fan use this 9 volt as well. 9 volt will also supply the MCU inside here. I will later explain. Give the 5 volt, and this here is another 5 volt regulator. I seal it with the silicone. This is the 5 volt regulator. So there are 2 5 volt regulator, one inside, one is here. This one is used for something wrong. It seems something wrong. For this heater fan, and here is the temperature sensor, is the NTC sensor. I will explain later. And here is a bed of desiccant. Let me take it out. It's a little bit difficult. Use this type of. This is the reusable, rechargeable. And once the moisture absorbs into these pellets, it will turn to transparent. After heating it up, the moisture came out and it goes orange. And for these panels, let me show you what is this, where it come out. I take it out from this slow cooker. You can see this is a pot. If you can get this in market or a used one, you can take it out for use. This model is popular about 10 to 20 years ago. That time I took it from a company. I didn't buy these cookers. I just from my friends give me this. He give me this panel, so I use this parts for for my dry box. And if you can buy a used one and take this out, and you can use it in here, and I explain how to use it. And inside is a electronic board, and two pieces. The main board is here. It contains the MCU, and this here is, I take it out because it blew out. This is a triad, and there's nothing more. And here is there should be a LCD. It's not an LED. This is LCD, you can see here. And 4 digits LCD, and here is the buzzer. And the second PCB is the touch panel, and this is the electrode plate. And between this PCB and this panel, this is a transparent plate. Under it, there is also a overlay plate, plastic plate, and it will, for the light guide, the LED here will shine it into this overlay and have light here, so it will give light from here. There is wording here for the, but can't read here. Maybe these pictures can be seen more clearly. Yes, this one. You can see here, this is the, something is the low cooking. This is the power. And if use this PCB together with this plus panel, then it can come out all the wording. And actually I have finished doing the conversions, and it's not difficult because no much programming. And I will explain this. Firstly, I draw the schematic of it. This is the schematic. It's not here. I just roughly do it. So to do the conversions, I need to understanding all the things of these PCBs and how it functions. Firstly, the AC line come in here, and normally it will rectify to give a positive 5 volt, but here it rectifies to give the, you can see here the dial, it will give the negative 5 volt. Here Anyway, I don't go much details on it. And here is the live AC live part, live AC live. One is the neutral, one is live, and one is for high live. This is for heater. Heater will connect to this one, and yes, this one. This is the heater and the neutral. So the triad will control it, and the triad gauge here is controlled by its voltage or on off, or using PWM. I don't really know this because I don't know how it programmed the MCU. Anyway, this line go into the MCU here, and I don't need to know that things. I just cut this out. Cut off these two lines, and I just use this triads to control the heater, and the heater I will connect to my PTC heater, and I also use the MCU, the timer, and also use the touch buttons for selecting the temperature setting. There's time and temperature setting, and for the detection or the sensing of the temperatures, I will do it on my own. And for the control of this triads, I cut out this line and take it out to my components. I added the components. This component and my MCU will be stored inside here. I added a component is the optocoupler. This is the MOC VO21. I draw in double. Actually, don't look at this, just this. So 5V will give this LED or inside, and this line will go to my MCU. My MCU pin number 15. So my program will control this optocouplers to control the triad on this board, to turn it on or turn it off. But when and what temperature will turn this on and off, this controlled by my MCU. And I draw this also. I just repeat this one from here and here. So this line, these output lines will turn this triad on and off. That's same as this one. Now going back to the MCUs, I use this Pickcon MCU. and it is installed inside here. There is a rectangular PC board inside this housing, and this is the door, so you can see this one here. Actually, I don't need this Wi-Fi. I just use this tab, okay? But anyway, no problem. So I can plug this line to program it. So I can plug this into here and program the MCU. And this now come in very cheap. I think it just costs a couple of $. And for the MCU, right, for my MCU, I need to have the signal from this board. Which button is activated? There are 3 buttons. Instead, I will take the signal of the LED. When this is touched, this LED turn on. So I will take this signal, and this is the signal is PCB2 cap sense. This cap sense is here. This from here. This signal, one of three buttons come here. In my circuit board, I will have this 2 resistor and pull it down. And this is a voltage divider, because I need this, because this LED in normal condition, normal state, it will turn on a little bit. So I have this voltage divider to take a lower value, divide it to, let me check it out. Anyway, I don't explain much more. For the high and low value, I will have these figures to trigger my MCU, so I get the signal which button, which temperature levels it was selected, and then for my program to use. And the second function of my MCU is to detect the actual temperature inside the box. I already explained there is the sensor there. Is from the NTC sensor, is also come from the original slow cooker panel. So I don't need to buy or to get one piece. I just use it. And I found this NTC, I measure the resistance. It is a, and this tab NTC 100 k ohm resistance at 25 degrees Celsius. And I get this table, this tab of NTC, and this is the 25 degree temperature and 100 k ohm. This tab. And once I have this, I also make a circuit here to take the sensor voltage from here. And also it is a voltage divider. And after I get this voltage, I will feed this voltage into my MCU ADC. And this, there is three ADC pins I can use. I choose to GPIO 26, yes. And I need to do some calculation here, and I have 3 temperature setting. If I go to low temperature 14 degrees, I check this out from the table. And 14 degree, you can see here, go to 14. This is 15.5 kOhm. Something, so I 15.3, and here is 12K, and here is 20K. So there is 3 resistor, and this voltage come out and have a portion of the 5V voltage, and the 5V voltage is represented by this value. This is the 16-bit, and times this is this value here, and this portion is, this one is 22, and this one is 3 value come together, and now it is 13.3, and this is 2, this 2 is fixed value, total is 24, and multiply them and come out this value for this temperature. Do it same for the 2. For the 18 degrees, I get this one, because at 18 degrees is 12K instead of 15.3. So 12K plus 13.4 here, this 20 plus 13.4 is 20. So I have this 3 value for my program use. So now I can go to the program. Put this in. And one more thing here. For this original board, this is the cap sensor IC, and there is a 7 pieces of LED here, and here you can see the additional wire connection, 1, 2, 3 red wires going. I add this, and this pump is for the 3 outputs from the button LED, 1, 2, 3, and one is the ground. And originally the 2 boards are connected by this. I changed it to have the connector. Originally it was directly connected with ribbon wire from here to here, and from the schematics that I investigated and drew this board is the cap sense board, and this is the output line. There is several color, and with the names here, power. This power is the, I think is the this power on button. VDD, ground, SDA, SCL for I2 transmission connection, and here is the attention, and start is this button. This is the start button. Anyway, just for the knowledge, and here is I connect the web wire to get the outputs, and for the main board I connect 2 wire red and black to get the 5 volt. There's something, I think something here is not very clear. There is two electrolytic capacitor, 1000 microfarad, and this 417. I think here 4.9 volt, 5 volt. I connect this to have the power supply for my additional MCU. I don't remember if it was this voltage will be off when this timer timeout, and here is also the, so for the purpose of the operations, here is the wire, the copper tracks are disconnected here. There's here. I explained this before. This black wire will go to the optocoupler here. Actually, this white wire is come out from the MCU. It will give the signal when timeout. Then there is no voltage here. So actually, I can use these signals to feed into MCU one of the pins and get the signal to turn it off. But in my programs I haven't did it. You can do it as well. At the center, my electrode plate is just a square pieces, so the boundaries still have the light come out, but the center is blocked. Why I put this in this manner? Because if I put the electrode plates like this original PC board, it cannot be sensed. The sensitivity is not good enough. So it is a bit confusing, because I just talking about this one is totally my built one, and this one is, if use this method, you can just use this and don't care about what I talk about here. You just use it, this okay, and have all the things like this, and have the wording can be seen. Now going back to this method, this method used the original PCB two PCB and adding my program and MCU to control it. And I don't use this MCU, I just use the triad and I also use this MCU as well for timers and also for the button, for the 7 piece of button, 1 2 3 4 5 6 7. That's all. For other things of controlling the triad and the temperature and for the signal from the temperature sensor, I will use this my MCU to do the controlling. And I have the coating for it, and the program is very simple, and I open it in just a notepad. So here is the optocoupler pin number 11, the temperature NTC sensor to analog to AD to digital conversion pin 26, and 3 button pin, input pin that I said before, coming out from the original CapSense PCB board, the 3 LED. And firstly, default value for the optocoupler will be 1, because this one here is the high level will turn off this optocoupler. Here is the loop. That's all. That's ended. Only this one is for the 3 button pin. If this one is low, it was actuators. This the lowest temperature button actuators, and this is no actuators. And then if the temperature reading, NTC temperature reading, larger than this, if this value is higher, it means the temperature go above this value 14 degrees. It will then turn off this heater or the optocoupler, turn off or the try off, otherwise turn it on. This is for the 14 degrees lowest temperature setting. For the other two, do the same, and default value is this, else we turn the heater off, and just looping this and just this. Also, the heater also will turn off when the original MCU counters the timer ends. So because the voltage for my MCU here 5 volt, it is come out from here, from this original board. So when the timers ends, it will it will turn off the machines and have no power. So at the same time, here, as I remember, here is also have no power. Go to this triad gauge, and this will turn off. So here I have built this and done this and tested it operators and function. However, why come to here I do it one more PC board, because I accidentally short out a AC line and blew out the not only the triads, all the MCU here, and this cap sensor IC also not function. So I need to build on my own pieces again, and it's quite complicated for to make this a new one, and I may try to explain it quickly. And I don't recommend to do so because it's quite complicated. I strongly recommend us to use the original board, and if you have similar slow cooker or some other electrical appliance panel boards, you can make use them similarly. One more thing is to test the power outputs from the triads. You can do it the same as me. Use this old tap, filament tap lamp, and connect it to the power line, so you can see if this is on or off. Or if you use the PWM, you can see the power levels coming out, if this lamps brighter or not so bright, you can see it. It's very useful. And for my doing, and for the mechanical constructions, this piece, these two pieces, or these pieces, 3 pieces, and this tie parts, these two ties are 3D printers. This back cover this is the screw hole for locking it on the dry box container. And these pieces this screw post for securing the small PC board. And this is the door cover. this ledge here and slide it into the body. I cannot make this. And here is the PC board. This is the MCU, and plug it here. This is the component. This is the optocoupler. This is the connector. Here is the two connector and a power switch. Here connector, AC connector. This is the DC jack. And whenever I dry these filaments, I will put it into the seal bag for storage instead of letting it in this box, because the sealing performance of the vacuum seal bag is better. So after a while, if I use the filaments, I will take it out from the bag and put it into this dry box and to oven to dry it for a short periods of times, and also during in the use in the 3D printer. Thank you for your watching.